And welcome to the Smart Science measurement video about sliding masses. And in this lab, you're going to try to figure out how acceleration changes for a sliding object on a ramp when we change the angle. So we're going to look at a number of different angles, 15 degrees, 20 degrees, 25 degrees, 30, 35, and 40. So you can compare, say, 15 to 30 or 20 to 40, what happens when we double the angle. Also some other angles in between that might be interesting. So now that you're on the Explore page, you've already done your Engage, you've read your warm-up section, you've done your questions. For the warm-up, you can look at a brief diagram of what this lab looks like. You can also see a guideline, the instructions on how to do the lab. Notice that we're going to click on the top of the sliding mass that moves down the ramp in this lab. So just nice, precise point, that top of the sliding object, real easy to measure. Let's go ahead and do this. Before you start the lab, consider the question, how does acceleration change for a sliding object when the ramp angle increases? And you're either going to pick a hypothesis or write one. In this case, I picked one from a list just by clicking on it, and then it goes into this box right here that says hypothesis. So you can see what you've chosen. Now let's go ahead and run an experiment and see if we can have any evidence to support my hypothesis. I'm going to press play. We're going to see I chose 15 degrees for an iron slider. The bottom of it has Teflon, so it will slide better than if it was just metal. And you can see it heading down the ramp right there. Now, as the instruction says, we're clicking on that top point of the slider. Let's do that. Each time we click, a little bit of time goes by, and we measure the position of the glider. So as you do this, points go in your data table, and on your graph, you'll notice it's about 200 milliseconds in this case for this video for each click, which means after 5 clicks we reach 1 second, after 10 clicks we'll reach 2 seconds, and along with that we also have our distance calculations here. So really what you want to figure out is what the acceleration of this object is. Compare the acceleration at each different angle for this iron slider. You might have to calculate acceleration, right? So just go back and find out if you have some kind of formula for between distance, time, and acceleration. Okay, distance equals 1/2 at squared. So if we know the value for distance and we know the value for time, we can calculate acceleration. Again, distance equals half of the acceleration times the square of the time. Work that out, figure out how to move that around so that you can find acceleration based on distance and time. Now that you've done all this, do your measurements, compare your graphs. Notice we can save the graph we made it. It goes up into our list here, and then we have more than one graph. We can use the All button to compare them. Hopefully you learned something about how this angle changes the rate objects slide down the ramp in this Smart Science lab.